Good morning and welcome to the Wisconsin Manufacturing and Technology Show live from State Fair Park in West Dallas. I'm Ben Sherman, along with Scott Arnett, the president and CEO of the Arnett Group, and Rick Tufte, the CTO of LiquidCool Solutions. This is one of the big events of the year for manufacturing in the state of Wisconsin, and especially as it applies to the increasing influence of technology and where the entire business is going. Now, the purpose of this podcast is to talk a little bit about liquid cool servers and the growing impact that that technology is having on manufacturing as well as other aspects of business. And so I'm going to start with Rick. And let's do a little bit about the history of liquid-cooled servers, liquid-cooled technology. Tell us a little bit about that.
Well, sure. So the company was started in the 2009 timeframe. It started out initially working on highly overclocked gaming systems. So the technology that we're involved with is the use of dielectric fluids to provide immersion cooling of high-performance electronics. It's a substitute for traditional use of air cooling on computing systems and other kinds of electronics. And there are many benefits of using immersion technology for computing systems. Among those benefits are the ability to isolate the electronics entirely from the ambient environment because they're fully immersed in an enclosure with a conductive fluid that takes all the heat away and can be rejected either locally or at a distance. It's also a very efficient technology, takes much less energy to cool electronics than air cooling does. There are no fans involved, just very low-powered pumps to circulate the fluid. So today we're going to talk about the applicability of this technology to the manufacturing and harsh environmental market. There are other applications as well, but today the focus is on that application.
Scott Arnett from the Arnett Group, you work closely with LiquidCool as being part of your portfolio of solutions. How do you see it in liquid cooling in terms of the technology side and where that's leading in the manufacturing space as well?
Yeah, absolutely. Customers that are looking to take compute power out on the manufacturing floor, get it closer to the process of their manufacturing or food process or wherever it may be. And so the demand from a customer perspective is, how can I automate and get compute power out there? So us being able to partner with LiquidCool and get a solution to our customer that they can benefit from, both from an operational perspective as well as their overall operation, is very beneficial to us as well as to the customer. And so it's been a good partnership of bringing that technology solution to our customer base. So
if you do come to booth number 1132 at the State Fair here, you will see an example of a server in a fish tank with goldfish in it being giving an example of liquid cooling. But Rick Tufte, this isn't really bleeding edge technology. This has been around for about a decade and is more of a mature and settled technology, is it not?
So we didn't actually do the first innovation of immersion cooling. If you think about it, some of the earlier embodiments of immersion cooling technology might date back to the days of Cray and other companies. We've adapted it in some unique ways based on current technology and currently available fluids. We have a patent portfolio of 52 patents that are already issued. And so it has been under development and has matured rather dramatically over the last 10 years.
Tell us a little bit about some of the particulars and the advantages over air cooling. In this day and age when manufacturers and all businesses are trying to be more efficient, Gold Star certified, etc., tell us how this is an advantage and what the advantages are.
Sure, there are a couple of ways this technology can be contrasted with traditional approaches to air cooling. if you think about ruggedized computers as they've been available in the marketplace over the last couple of decades, most of them take the form of being kind of sealed units that rely on conduction to get the heat out to the skin of the device, and then fins or something to kind of exchange that with the air. Most of those devices, they're limited in the amount of power that they can actually consume because of all the thermal constraints of that approach. And their power output is generally in the range of tens of watts, perhaps up to 80 or 90 watts. In the case of immersion cooling, where we can move the fluid through the systems to take the heat away and to transfer that heat away to the environment in different ways, the limits on that have been vastly increased. So instead of talking tens of watts, we're talking hundreds of watts or thousands of watts. There's really no constraint on how much power you can commission with those ruggedized systems out there. The other contrast is that for the systems that are often used in harsh environments where the power levels are higher, they have to run all of the air through filters, which is an additional restriction. And the fan power is actually a significant percentage of the total power that the system consumes. It's not unusual for the fan power on compute systems and server systems to be in the range of 15 to 20, even 22% of the total power draw at the plug. With our technology, that number is more like 2%. So there's a lot of energy savings available out there for edge or ruggedized types of applications for compute.
At Arnett, you have a large portfolio that you present to your customers. And this, the liquid cooling, I think, is an emerging technology. And how does this help you vetting a potential customer as to what would be a good candidate for liquid cooling technology?
Right. So I know we're here talking manufacturing
Right.
at the show here today and stuff. So there's several different verticals. Microphone issue here. So customers, it gives us the capability to help them solve a technology need that they currently have. So whether it's, like I said, automation, it's looking to collect more data from probes and sensors and stuff, and that, to build a operational database, do analytics, that type of stuff. It gives the capability to get away from the traditional PC out on the harsh environment and stuff, where there's a high failure rate because of the environment, that they can be very creative in this solution. Extreme cold environment for frozen pizza in the freezer, to a very wet environment, very hot environment, that they can get closer to the process where they're trying to either make decisions with the compute power, collect data, make decisions, that type of stuff. So having this in our portfolio gives us that flexibility to understand and learn what the customer's goals are, and then align technology to those goals that best fits their needs. So it really complements what we're trying to do for the manufacturing customer all the way around.
I'll put this to both of you. Can you give a definable return on investment, the amount of money that a customer can save with LiquidCool technology over air-cooled? Have you developed an ROI or maybe a TCO?
Well, I can start with one customer example. We have a recent customer that we've been working with, is a large distribution center. One of their challenges has been is they have a latency issue going back to the data center with all of these sensors and probes and that type of stuff to run their operation. Automated forklifts, automated pickers, that type of stuff. So if you watch the operations for the entire day, it's a lot of start, stop of this equipment as it's waiting for its next command because of the latency. Being able to bring the compute power out onto the floor direct and do away with the long distance circuits, the latency, that type of stuff, it speeds up their operation, that it's a much smoother flow to all their equipment. Those start stops over an entire 12-hour shift or a 24-hour shift really adds up. So they've been studying it for the last several weeks here. Of they're up about 8% right now in operations efficiencies of the equipment. The other issue that they were having was because of that delay, they were selling stuff that they no longer had in stock online because there was such a latency delay of updating inventory. They'd have to refund the customers. They'd have to redo the order with the customer. So they had a lot of labor involvement in redoing orders and customer satisfaction issues. And so now it's more real time than what it had been in the past because this is out on the floor producing data and stuff like that that's feeding their operations real time. So their goal right now is to get to about a 15 to 16% efficiency overall rating to their operation by having this closer to their operations. So that's their goal. That's what we're shooting for.
And in manufacturing, that's huge, right? I mean, those are the type of metrics that everyone from the CEO to shareholders to middle management is looking at.
Yeah, one of the other factors that would factor other people's return on investment models, or total cost of ownership models, is reliability and longevity. And one of the benefits of this technology is that if you look at some of the predictive failure metrics of electronics, one of those key metrics for device life is junction temperature of the semiconductors that are involved. When you're using immersion cooling, you're typically running 20 to 30 degrees C cooler at all the junctions on all the active devices in the electronics. And if you use that to look at projected reliability or life of the devices, that translates into a 4x to 8x improvement in the usable life of those electronics. So the fact that you can expect to have longer useful life of your electronics is going to factor into your cost model. And it can be a pretty big number. So that adds significantly to the benefits of how you look at this technology as an investment.
Where is the future of LiquidCool technology going? What are some of the advances you're looking into now, technologically, both primarily in the manufacturing side, but what's ahead for LiquidCool?
Well, I mean, the physics are pretty established. What we're doing is we're focusing on adapting the technology to a variety of marketplaces. The industrial and harsh environmental one is one of the ones that we think is an easy adaptation and adoption strategy. We're also looking at the migration of compute systems that are normally in the cloud or in the host data centers, moving out closer to what we call the edge, primarily to reduce latency and be more responsive. A lot of high performance computing that used to reside in big data centers has to move out closer to the end use, closer to the towers that are involved with 5G and future versions of telecom technology. So the ability to migrate that high performance compute out into non-data center environments is an obvious one that's going to play a big role in the growth of the adoption of the technology. And of course, even in those large data centers where high performance computing will continue to kind of drive forward in terms of power densities and stuff, it will also find a place when rack power densities start moving up north of 20, 30, 40, 50 kilowatts, and air just comes up short as a cooling theme.
Are there tax benefits for companies that have this technology? We know there are for solar and some other energy-saving technologies, but has it gotten to that level where there are some tax advantages as well?
Well, I think the tax advantage is one that will probably evolve with a focus that's going on green technologies and carbon neutral type of focuses. But some power companies are already evaluating the technology and coming up with incentives to discount cost of power for large-scale adoption of the technology. So there are some incentive type of motivators for the adoption of the technology that are beginning to surface, and they'll become a bigger, aspect of purchase decisions in the future.
We've been talking about LiquidCool technology with LiquidCool Solutions CTO Rick Tufte, and as part of the portfolio of the Arnett Group with CEO Scott Arnett. We are at booth 1132 here at State Fair Park at the Wisconsin Manufacturing and Technology Show. I know you gentlemen will be here for most of the day. If people want more information from the Arnett Group and to look into this a little bit more, how would they contact you?
Yeah, absolutely. So email at arnettgroup.net. You can call us at 920-261-2037. And of course, we're online at www.arnettgroup.net.
Rick, for LiquidCool.
So for Cool Solutions, if they simply go to our website, there is a portal on there to submit contact and information requests right on that website, and that's liquidcoolsolutions.com.
To both of you, Scott and Rick, and thanks to all of you for tuning in to this podcast. Again, we're here, booth 1132 at State Fair Park. Have a great day, and thanks for joining us.